Hello. The objective of today's exercise is to apply the knowledge of the modeling process of machine learning to solve combined cycle power plant problem. Our model is dependent on some variables such as atmospheric pressure AP, exhaust steam pressure V, ambient temperature AT, and relative humidity RH. These variables can be termed as input variable or feature variables or predictor variables. Our output variable or the target variable is the full load electrical output. Our task in this problem is to apply machine learning for developing a predictive model to predict the full load output power of a CCPP power plant. Further, we want to evaluate the performance of the model for the best output. Our dataset is based on the data provided by Pinar Tufekci and is available on UCI data repository website. Data is composed of 9,568 data points and is collected from a full functional power plant over a period of 6 years. The problem can be modeled as a multiple regression model because we have some inputs and some outputs, and the mathematical formulation of the model can be y is equal to b1x1 plus b2x2 plus bnxn, where xn is the feature variable, b is the regression coefficient, and y is the output or the target variable. Further, we elaborate on the steps of developing a machine learning model. First, we do an exploratory data analysis on the available dataset to see the quality of our data. If we have too many missing values or too many duplicate values, we would want to get rid of that. In this dataset, out of 9,568 data points, we have 41 duplicate points which we have dropped from our dataset. The second step is to develop the model. The third step is to evaluate the model, and finally we have to select the best model. After cleaning of the dataset, we find that our data is of good quality, and we use the correlation matrix to plot the heat map using Seaborn library. After plotting the heat map, we can see that AT and V variables have strong negative correlation with our output variable or PE. Then we do some permutation and combinations to see what is the best combination of our feature variables for the best output. We select 1, 2, 3, and 4 feature variables. Since our data is clean and we want to include most of the features, so as predicted, and after doing several simulations, we find out that the 4 feature input model is the best possible model for our machine learning exercise. We can also do a pair plot to visualize the bivariate distribution of dataset, which we have done in this exercise. The next step to solve our problem is to train the model. We then divide our dataset into 80% training data and 20% test data. We run 5 algorithms: linear regression, decision tree, random forest regressor, gradient boost regressor, and ADA boost regressor. The final results, why we have chosen random forest, are presented in our PowerPoint slides. Thank you. We present our final prediction results of our machine learning modeling algorithm. We can see that the random forest regressor and gradient boost regressor have almost the similar output, but the final prediction of random forest is slightly better than gradient boost regressor, which is 95.67% accuracy. Then we see linear regression and decision tree regression. Our output for linear regression is 92.03% accurate. For decision tree regression, our output is 92.58%. And then we also do AdaBoost regression, where our accuracy is almost 85.64%. So we have a reasoning why we have selected random forest model.